Alright, 7.2, a little quick set of notes today on ratios and similar polygons. So we're going to start off by defining what a similar polygon is and bust into some problems here. Give myself some room. Alright, so similar polygons are basically polygons that have congruent angles and proportional sides, and I'll talk a minute about what proportional sides mean. Congruent angles mean the angles, they're all equal, they all match up. Basically, another way to think about this is that they are the same shape, okay, same shape, but different size. So one is just a smaller version than the other one. It's kind of like if you snip a picture off the internet and then you hold shift down, and when you change the size of it, you keep all the proportions the same and you don't make it skinnier or fatter. So talking about the angles, so when I do the congruent angles in this picture over here to the right, I have A and E match up. So angle A would be congruent to angle E. And I'm not going to keep doing all the symbols, but D would go with H, and B matches up with F, and G matches up with C. Alright, so all these angles here are congruent. I guess I will go back and put in the symbols. Doesn't take that long. So for this shape, since it has four sides, there's four congruent angles. Now, the sides that are in proportion, okay, what I mean by this thing right here, proportional sides, these sides are called, they correspond to each other. So corresponding sides, they're not congruent, but they kind of match up with each other. So we're talking like AD, which is on the smaller shape, should match up with EH. AB should match up with EF. So when I do a ratio of the side lengths, FG should go with BC. Now I made a mistake here. I started to put the big shape on top, and you need to put, if I'm putting the little shape on top, I got to keep that consistent throughout. So I have AD, I have AB, I should now go to BC, matches up with FG, and then HG and DC match up with each other. And the sides aren't equal, but these proportions, these ratios or fractions should all be equal. And I'm going to kind of break that down here in a second. So one important piece, I'm going to kind of make this really big up here at the top. This symbol right here is a symbol for similar. Alright, that's how we show in symbols that two shapes are similar to each other. So when I write a similarity statement, I'm gonna talk about these shapes up here. Well, since it has four sides, I got to name the little one as ABCD. Quadrilateral ABCD is similar to EFGH, and I have to be careful, just like with triangles, that the angles match up with each other. That A and E are the ones that are equal to each other. B and F are the ones that are congruent to each other. Now, a similarity ratio is basically when I write down the sides as a fraction. So if I'm looking at it and I'm doing it for ABCD to EFGH, that means I got to put ABCD first, all those sides on top, and the bigger ones on the bottom. So let's match it up. AD is 5, this side, and that should match up with EH, which is 10. And I should be able to keep going around here. When I look at the next side, I have AB matches up with EF, so that's 6 over 12. And I'm going to do another side here. FG and BC go together, so 5.4 over 10.8. And then finally I'll do the last one, DC and HG. If I check out all these fractions and I either whittle them down to the reduced fraction or I change them to decimals, they all break down to 1/2 or 0.5. And that's what it means for the sides to be in proportion. All these fractions are equal here. Now, if they want the ratio from big to little, so this is from the big to the little shape, then I have to just reverse all those numbers. So I'd have 10 over 5, 12 over 6, 10.8 over 4, 5.4, and 8 over 4. So that similarity ratio would be 2. So similarity ratios just depend on which order they ask. Do they want from small to big or big to small? Now scale factor is the number you multiply all dimensions by. So scale factor is pretty much the similarity ratio, but going from big to little. Okay, so 2 would be the scale factor here. Alright, let's move down. Do some examples down here at the bottom. This will get us ready for our homework. So the two polygons are similar. They give me that. Write a similarity statement. So I need to say exactly who's equal to who, and I just got to be careful that I match people up. So let's just say I go over here to the right and I start at D, and I go D, G, F, E. Well, now when I do the second one, I got to kind of be careful because I got to figure out who matched up with D because that was my first letter. Well, that would be S. And then my second letter was G, which is right here, and that corresponds with R. And F corresponds with Q, and E is congruent to P. So this is what's called a similarity statement. Now notice when you have four sides, there's no symbol in front. You know, with triangles, like over here, I have a triangle symbol. I don't have a symbol when there's four sides. The problem is there are too many different shapes. There's squares, rectangles, trapezoids, rhombuses, parallelograms, and so I can't really put a symbol in front of the four letters. Alright, so number 2, are they similar? Well, there's only one way to prove this. I have to prove by showing that all sides are proportioned, and I also have to show that all angles are congruent, all corresponding angles. And we're going to assume the angle part because it doesn't look like they're labeled up here, but I'm going to assume that D matches up with N, and C matches up with L, and M matches up with E. But now let's check the sides. So let's put the sides in proportion. So I'm going to do 2 is to 2.3. I have that set. And then I'm going to do 1.5 is to 1.7. And then I got to look at 1.4 to 1.6. And I got to ask myself, are these sides in proportion? Well, one way I can check is that I could change those all to decimals. So I'm going to punch in my calculator 2 divided by 2.3. 2 divided by 2.3. And I get 0.8695 and some other stuff. And let's check the next one, 1.5 divided by 1.7. This one is close, but it's not the same. It's 0.8823, blah, blah, blah. And when I do the last one, 1.4 divided by 1.6, I get 0.875. So the sides are not in proportion. So the answer to the question is no, they are not similar. Those decimals down there have to match up exactly. Alright, next one says find the similarity ratio. Remember, ratio is just a fraction. So I got to find the similarity ratio. And I don't care if you go little to big or big to little. So one way to write it, I see that 15 matches up with 18. And then I also have 30 matches up with 36. And now I just basically have to check these two. Now with fractions, sometimes you can just reduce it down as low as it'll go and your fractions will match. Sometimes it's easier to do decimals. I'm going to reduce these down. 3 goes into both numbers right here. 15 divided by 3 is 5. 18 divided by 3 is 6. Over here, if I divide both these numbers by 6, I also get 5 over 6. So that is the similarity ratio. The similarity ratio is 5 to 6. Now, if you were going to do it the other way from big to little and you put the big ones on top, it would be 6 to 5. So either one of these are good. Depends on what order they ask you. Now, number 4, this is what you're going to be doing the majority of on your homework. You know that they're similar, but you have to solve for a missing side. Let's just call that x. So how you find the missing side, this is very important. You need to set up a proportion. Okay, set up a proportion, and then you're going to cross multiply to solve for it. So let's set up a couple ratios from the picture. 2 numbers that I have for sure, and it doesn't really matter who I go with, but I see I have 32 matching up with 24. Now it doesn't matter if I do 32 over 24 or 24 over 32. I just have to stay consistent. So I'm going to do the big side that corresponds with the little side. And then I'm going to do the big side that corresponds to the little side. And that's how I kind of sneak my x in there. And now I'm going to be able to cross multiply and solve this problem. So I cross multiply, I get 24x equals, and 32 times 18 is 576. And divide both sides by 24. And I get x equals 576 divided by 24. Comes out to be 24. So it looks like this missing side over here is 24, and things will stay in proportion. So that's going to be a very common move throughout this section. Alright, let's head over to the back page, see what we got over here. Find the missing side. It says the scale factor from A to B is 5 to 6. So from A, the little, so we're going from little to big. Alright, so I want little on top. So little is 5, big is 6. So 5 is to 6 as, and then on my picture, little to big would be x over 18. And I cross multiply here, and I get 90 equals 6x, and divide, I find out that x equals 15. Number 6, solve for x. Scale factor from little to big is 4 to 5. And I got to do this. 20 is the small. 4x minus 3 is the large. Got to be a little bit careful here going through. 5 times 20 is 100. 4 times 4x is 16x. But then I got to remember to do 4 times negative 3. That's negative 12. Solve this equation. I add 12 to both sides. I now divide by 16, and 112 divided by 16 is 7. So x equals 7 for this one. Alright, moving on down for the last couple here. So number 7, each pair of triangles are similar. Find the missing side. You can leave that open, bud. Don't worry about it. So first I want to match up the angles. Who goes with who? Well, because of vertical angles, I know these two are a pair. Just looking at the other ones, I'm going to assume here, I think I have to, that G and L match up, and then M and H are the final ones that match up. So I'm going to call this over here, this is the little, and this is the big. And I'm going to set these up little over big, and we'll call this X. And now I got to pair up sides that I know go together. Well, I believe that the 70, that hooks up between the 1 and the 3 arc. So that's going to be partners with 40. So 40 and 70 are a pair of congruent side, or not congruent, corresponding sides. And then I got to get involved the side here that I'm looking for, KG, which is X on the little one. And then for the large one, that's going to match up with 49. And now the rest is algebra from here. I have 70x equals 40 times 49 is 1960. And I'm going to divide both sides by 70. And the answer would be 28. So the missing side there was 28. Now number 8 is a little tougher. Number 8 is what we call overlapping triangles. For some people it might be easier for you to break these up. So I might redraw this. Sometimes it's easier that way. K, J, and L. And then over here to the side, draw the smaller version, which is V, L, W. Now some people may not want to take the time to redraw the pictures. I just kind of like to do it. So what do I have here? From K to L is 54. From L to J is 72. And then on the smaller shape, I have 24. And I have, I don't know, or I have X. So let's set this one up. Sizes are in proportion, so I have the 54 and the 24. Maybe this one I'll do big over little. Big over small. And then the key is I just got to do big over small again. So the other side I have big over small. And again, cross multiply, 54x. 72 times 24 is 1728. Divide that number by 54. And we're looking at 32 would be the answer here. And finally, last one. This one's a little bit rougher. This one's got some variables in there. It's just a little bit tougher. So final question, number 9. Solve x for the similar pairs. I'm going to attempt to do this one without redrawing. So my missing term here is the 3x. I got to figure out what x is. So I see that the small triangle right here, that one is going to match up with this larger triangle, which is out here. And the dimensions for the larger triangle are 32 by 3x. So let's kind of match these up a little bit. I'm going to go little to big. 8 on the small triangle should match up with 32 on the large. And 9 on the small triangle should match up with 3x. And again, we get to a familiar spot where we do our algebra. That's 270 and 18, which would be 288. And divide both sides by 24. 288 divided by 24, and the correct answer is 12. Alright, I think that's enough to get you started on the homework today. See ya.